All right, so this is the fundamental theorem of calculus, part 2. All right, so we talked about the first one, which is where you take the derivative of the integral. So the fundamental theorem of calculus, part 2, let little f be a function that is continuous. If big F is any antiderivative of little f, then the integral of little f is big F. So basically we're saying the antiderivative, the integral is the antiderivative. And then you plug in your upper bound, you plug in your lower bound. Right? And that's pretty much it. So antiderivative of f, right? So an integral is just another word for antiderivative. Antiderivative. Right? So then we take that and then we plug in the top minus, we plug in the bottom. So it's pretty straightforward. There is a proof in the book, or you can Google it if you really want to see the proof. Okay, so the integral from -2 to 1 of x squared. So what would we do there? So start with your antiderivative. What's the antiderivative of x squared? So we add 1, so x cubed, and then divide by the exponent. Or you could do 1/3. I like doing the fraction. And then we're going to go -2 to 1. This is the notation. So I'm going to plug in 1. So 1 over 3 minus, then I'm going to plug in -2. So -8 over 3. And then simplify. 9 over 3 is 3. And that's it. So antiderivative, plug in the top one, subtract, plug in the bottom one. All right, pause and try the other 3. See if you can figure these out. All right, so cosine, antiderivative cosine is sine. So sine x from 0 to pi over 6. Sine of pi over 6 is a half minus 0. Sine of 0 is 0, so the answer is just a half. All right, whose derivative is 1 over the square root of 1 minus x squared? So this is just flat out memorization. That's your arcsine. Sine minus 1 of x from 0 to root 3 over 2. So what's the arcsine of root 3 over 2? When is the at what angle is sine root 3 over 2? That's 60 degrees, which is pi over 3. And again, 0, arcsine is just 0, so pi over 3. And then the last one, whose derivative is 1 over x? That's the ln of x from 1 to 2. So that's ln of 2 minus ln of 1. But what's the ln of 1? That's just 0. So our final answer is the ln of 2. We're done. So antiderivative, plug in the top, minus plug in the bottom. Notice we do get a lot of zeros, but we don't always get 0, so don't fall into that trap. All right, find the area under the curve of e to the x from -1 to 1. So area under the curve is your integral. So e to the x from -1 to 1. Find your answer. So what's the antiderivative of e to the x? Well, that's just e to the x. -1 to 1. So I'm just going to plug in 1, e to the first, minus e to the negative first. And you could just leave that. That's the answer. You could do e minus 1 over e, have a common denominator, right, times e times e. So if you really want to go for it, you could do e squared minus 1 all over e. Both of those are correct. It doesn't really matter. The only thing would be if this was a multiple choice on the AP, it would probably be written like that. So you would need to be able to rewrite it. Okay. If the antiderivative of velocity is position, what do you think this means, right? So if we have position, right, its derivative is velocity. So if we're going backwards, what do you think the integral represents, right? This is position, right? The antiderivative velocity is position. from A to B. So that's x of B minus x of A. Well, what is that representing? This is representing displacement, right? It's where you ended minus where you started. We don't really care what's happening in between. Like, we could be, like, if you're in a car, where's my, that's a truck, right? He's driving this way, and then this way, and then here, and he ends up here in the end, right? You went a bunch of places, but the distance from where he started to where he ended is, say, 2 miles. It doesn't matter that he went 5 miles this way, back 10 miles, another 4, like, that doesn't matter. It's just where you started, where you ended. So, like, the integral of my day is 0 because, or of the integral of my velocity would be 0 because I start at home and I eventually end at home. Okay. So, displacement is what the integral is. Now, total distance traveled, if we want to take in consideration, you went this way, then you went that way, then you went back this way. That's total distance traveled, and that's where we use the absolute value. So that's a lot trickier, because we have to take in consideration where is this graph below the x-axis, that type of thing. So we're going to do one of those, and that's the hard part for today. Okay, so we have a particle with a velocity of t squared minus 3t plus 2. What is the displacement of the particle from 0 to 5? So that's just our integral. Right, displacement is the antiderivative. So t squared minus 3t plus 2 dt. We're supposed to put parentheses around there. I skip it a lot, but you are supposed to do that. So we're finding our antiderivative, t squared, t cubed over 3 minus 3t squared over 2 plus 2t from 0 to 5. So I'm going to plug in 5. I get 125 over 3 minus, 5 squared is 25, 75 over 2 plus 10. And then minus, plug in 0, we just get 0. All right. So let's figure out what that equals. I'm going to cheat. In class I did it out, but I'm going to cheat and use my calculator. I got 14.16 repeating, 167, or 85 over 6. So that's the displacement. From start to finish, it went 85 over 6. Okay, now, total distance traveled, we have to take in consideration where this thing went negative. If we graph that's a parabola, right? What are the zeros? If we factor this, we get t minus 1 and t minus 2. Okay. So this thing is under the x-axis for this. So what we have to do is we have to integrate. We're going to integrate from 0 to 1. And then we're going to integrate from 1 to 2. But from 1 to 2, we have to flip the sign. Because what the absolute value does is it takes that part, this below, and it flips it up. So this graph actually looks like this. We never graph these. We don't graph these in Algebra 2, but that's actually what it looks like, this graph. Because then we're finding the area under the curve. So we have like that, this, and then this. So it's kind of weird. So we have to take the negative, because it's under the x-axis, we negate it. And then from 1 to 2, sorry, my brain stopped working, from 2 to 5. 2 to 5. All right, so we're going to go through and v of t, v of t, v of t. So we're going to go through and integrate. All right, so I'm just going to write out the t cubed. So I've got my t cubed over 3 minus 3t squared over 2 plus 2t from 0 to 1. And then my negative 2t cubed over 3 plus, because that negative outside, 3t squared over 2 minus 2t from 1 to 2. And then back to the original, t cubed over 3 minus 3t squared over 2 plus 2t from 2 to 5. So this is a little this is very not a little, this is very tedious. All right, so I'm going to plug in, so 1/3 minus 3 over 2 plus 2, and then minus 0. The next one, I'm going to plug in 2. I get negative 8/3 plus 6 minus 4, and then minus, now I have to plug in 1, negative 1/3 plus 3 over 2 minus 2. So now these don't cancel. A lot of students are like, well, oh, now this and this cancel. They don't, because this negative. They actually end up doubling because you have the negative out front and then the negative on the inside. So that becomes negative 1/3 is positive 1/3. And then this one, the 5 again, so that's 125 over 3 minus 75 over 2 plus 10 minus, now we're plugging in 2 again, so that's your 8/3 minus 6 plus 4. All right. So again, normally I would do this in my head, but I'm going to just plug it all in the calculator, see what happens. All right, so I did all that, and I ended up getting 14.5. So notice it actually wasn't a big difference because the 1 to 2 wasn't, like this piece wasn't below that much. So, all right, that's it, 14.5. Again, tedious. I'm gonna show you how to do this on the calculator so we don't have to do it all out. Typically, we do a lot of the total distance traveled on the calculator. All right, 2 more and we are done. So pause and try these 2 problems. All right, so whose derivative is secant squared? So that's tan x from 0 to pi over 4. Tan of pi over 4 is 1 minus tan of 0 is 0, so that's just 1. So for this one, I rewrote it, so that's 1 to e x to the negative 3 dx. So we add 1 and then divide by that. And then I rewrote it as negative 1 over 2x squared. Oops, not e squared, x squared. From 1 to e. So I plug in and I get negative 1 over 2e squared minus negative 1/2. So plus 1/2. So now this one, I need a common denominator. I said this earlier. So I'm going to rewrite it. 1/2 minus 1 over 2e squared. My common denominator is 2e squared. So I need my e squared here and here. So that's e squared minus 1 over 2e squared. E squared, so that's d. And that's it. All right, so here's your homework for number 69, and then there is a video. It's basically on this again, but it's how to do it on the graphing calculator. So we do a lot of integrals on the graphing calculator because it's really hard to integrate once you start getting complicated. So do this homework and watch that video, take notes on it. All right, have a fabulous day.